Today is 5-4, analyzing graphs of polynomial functions. So yesterday, we talked about odd and even. We talked about positive, negative LC. What am I? Odd or even? Even. Am I positive or negative LC? Positive. Excellent. Odd or even? Odd, positive or negative LC? Positive LC. Even, because they're both the same. Negative LC, because they're both down. That was yesterday. Okay? So, today, we're going to fill in the box. Yesterday we had a box. Today we're going to fill in the box. Okay? Extrema, turning points. It's your hill or valley. Okay? So this is a turning point and this is a turning point. It literally turned. Does that make sense? Okay? Relative max, relative min. Let me explain what it isn't. Okay? This is a maximum. It is the highest point on my graph. This is a relative maximum because it's not the highest point. Do you see what I'm saying? But if it's a hill or a valley, it's a relative max or a relative min. Does that make sense to you? So if this hadn't been here, it would have been the max. But because it is here, it's called the relative max. Does that make sense? Okay? So then this would be called the relative min, because it's not really the minimum, because there's more farther down, but it's a valley, so it's the relative minimum. Is that kind of okay? Okay. And then location principle, we've talked about this before. When your y value changes signs in a table, it means that it must have crossed the x-axis somewhere. So before this chapter, we said it was in between -1 and 0, and then we figured out better ways to do it later. Same thing today. We're going to be kind of guessing, not really a good way to do it, but that's just how I get you started. So after this section, you learn more accurate, quicker, better methods, but we just have to start somewhere. Okay? So, do this, graph the function, and we'll go from there. So we're going to graph it using a t-table in a second. Before we do that, let's use what we know from yesterday. Is this an odd or an even degree function? Odd, because it's 3, right? So, is it positive or negative LC? Positive. So the right side's going to go up and the left side's going to go down. That's the end behavior of this graph. Does everybody understand that from yesterday? Okay, great. So now we do a t-table. Typically you start -2 to +2. So these 3 rows, you're going to plug in -2. So Corey, Brianna, Sam. And then Sarah, Brooks rows, you're going to plug in -1. So plug those into the function and see what you get. Lean to a neighbor if you want to. Okay, -2 people, what'd you get? 18, very good. If you didn't, try again or ask me. -1 people. Excuse me, 8, very good. You just plug it in, right? Yeah. Sure. Uh-huh. Yes. Yeah, so Sarah's question was, if this hadn't have been in order, the degree is still 3. The LC is the coefficient on that. It should be in order, so that's why it's called the leading coefficient. But if it's not in order and you don't feel like writing it in order, it's the one that's in front of the highest degree. Is that okay? Yeah. Okay. Is everybody okay with those two values, the answers? Okay? I feel like if you can plug those in and get them right, you can plug them all in and get them right, so let's save some time. I'm going to tell you what the others should give you. If you feel like you need more practice, do some more, but I don't want to waste 10 minutes just watching you plug and chug. I feel like you kind of get it at this point. Okay? If you don't, you need to come and see me, and I will help you. 0, well, you could do that. What's 0 give you? 0. 1 gives you 0 as well, if you take your time and plug it in. 2 is going to give you 14. So everybody get that I plugged it in and you would do it if I hadn't have done it for you. Okay? Let's go by 2's on our graph. You go ahead and graph what you have the best you can, and then you see if that's enough. Okay? So I'm already going to tell you that that's not going to be tall enough on the y-axis. We're going to have to go higher. but you definitely need to go by 2's. If you go by 2's, you need to show me that you went by 2's. Okay? So 2, 4, 6, 8, 10, 12, 14, 16, 18 is good enough for me. All right. Negative 218 is left 1 tick mark, right? And up 18. Negative 1, 8, 2, 4, 6, 8 is left like a half, because that's 1 now. 0, 0 is still there. 1, 0. 2, 14. If that's 18, there's 16, 14. I don't know. 2, 4, 6, 8, 10, 12, 4. There it is. Okay. I wrote 18. That's kind of confusing. I think I'm going to get rid of the 18 so you don't think it's something else. Two, 4, 6, 8, 10, 12, 14, 16, 18. There's the negative 218. Okay. That doesn't look like much right now. Okay. This is a polynomial. Polynomials will never be sharp like this, ever. Okay. And they will never be horizontal, ever. So this is not going to go like that. But there we're missing something. All of these have to be connected by smooth curves. So what that means is I need to see what happens in between these two. Do you understand what I'm saying? It's either going to go up or it's going to go down. I don't know what it's going to do. So what I have to do is plug in 1/2 because that's in between them, right? And I end up getting, if you plug it in, negative 1.375. So what that means is go to 1/2 and go down a bit. So it's going to be a valley is what I'm saying. Do you understand there's no way to know that without plugging the one in between them in? I know it's kind of hard to see because we went by 2's, but...
That's negative, right?
Negative 1.75? Or 1.375? That's why I went down. If you plug it in, that's what you get. So, for right now, I'm going to connect these with smooth curves. Okay? So, it's kind of hard to draw in here, but I'm going to do the best I can. That's what I have right now. Okay? What's the right side of my graph supposed to do? Go up really high, really fast? I don't feel confident that it's doing that yet, so I'm going to put a couple more in. 14 is not up for forever. Do you understand what I'm saying? So I'm going to plug in 3 and see what that does. If you plug in 3, again, I'm going to save you some time, you get 48. Okay, now I feel a little bit better, right? 348 is up here really. I don't have to actually graph it. I just want to know that it's going up. Do you guys get that? Okay. What's this left side supposed to do? Go down. It's not. It's going up. 0, 8, 18. It hasn't gone down yet. I have to keep going. Do you understand what I'm saying? So I'm going to plug in negative 3, and I get 24. It's still going up. Okay? It doesn't mean you're wrong. It just means we need more. All right? So negative 324, I'll plug it in a second. So I need to do another one. Negative 4 gives me 20. Okay, it's finally going down a little bit, but not enough for me to feel like it gets an arrow. Do you understand that? So I'm going to do another one. Negative 5. Negative 5 gives me 0. Okay, we're coming back down, but not really enough in my opinion yet. Okay? Negative 6 gives me negative 42. Well, that makes me feel better. And I'm someone who really wants to make sure I got it right. I would have gone one more, and negative 7 is negative 112. Okay, yeah, we're good. Do you see what I'm saying? I'm not going to graph all those. I just want to know that I'm going down for forever on the graph. Does that make sense to you? Okay, so we do have to graph negative 324, so do the best you can there. I don't even know, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So negative 3 would be like right there. And then negative 420, if this is 20. I'm not going to keep counting. It's over here somewhere. I don't know. I'm going cross-eyed. So negative 420 is like right there. Negative 50 is right here. And then I'm not going to graph anything else because I don't have to go down that far. But again, you connect them with a nice smooth curve. So really, it's kind of hard because I pieced it together. It really should look like one really pretty graph like that. it shouldn't look so choppy, but I'm doing it on here one piece at a time. You understand that? Okay? So that's technically our graph. The right went up for forever, the left went down for forever. We filled in the box. Again, we'll find better ways to fill in the box later, but for today, a t-table is fine. Okay? So that was part A. Part B. Determine the answers, right? The 0, what's another way to say 0? X-intercept, right? When you find the x-intercept, if you're doing it algebraically, to find x, you set y to 0. So aren't all of these the answer? Where y is 0, isn't that the answer? Is there any guessing? No, I didn't guess anything, right? My x-intercepts are, what, -5, 0, and 1. Is everybody okay with that? Do you understand I did not guess? Because the y value was 0, that is my x-intercept. Before this chapter, we had a graph that would look like this. We were saying, I don't know where it is. It's in between -1 and -2. Do you see what I'm saying? That's what this was trying to say. Right here, determine the integer values between blah, blah, blah. We didn't have to do that here. Okay, it's not always that easy, though. That's why we have the other methods I'm going to show you later. Okay? Part C, estimate. They're saying, give me a good guess. Okay? Estimate the x-coordinates at which the relative max and min occur. So, the relative max is probably here, right? And the relative min is probably here. Do you guys see that? Let me point it out again. This is probably the relative max. This is probably the relative min. So, relative max, I'm just going to give the ordered pair even though they just asked for the x value. The relative max is at -324. And the relative min is at 1/2, -1.375. And that is a guess because maybe that's not the exact highest peak, but as far as our t-table goes, it's pretty good. Are you kind of okay? Okay. Anyone still need that? All right. Sketch. So what we did on the front was not a sketch. That was pretty precise, right? A sketch means probably you don't need to plug any numbers in, okay? So an odd, let's say positive LC, positive leading coefficient. An odd function with zeros at -5, -3, 0, 2, and 4. What's it mean to be a 0? X-intercept, right? So we have an x-intercept at -5. We have one at -3, 0, 2, and 4. This graph is going to cross the x-axis at those places. Do you understand that? Okay. If it's a positive odd, odd means opposite, right? And then if it's positive odd, the right side's going to go up and the left side's going to go down. Are you with me so far? All the rest of it, how do you have to fill those in? What do they look like? Swoopy-doos. Yep, that's what I said. So, just do the best you can, and that's your graph. Because they said sketch, right? Here's the thing. I don't really know how high or low those hills and valleys are supposed to go, but this is a fine sketch. It could have been like this. I don't know, though. Do you understand what I'm saying? Okay? Questions? Go back to this real quick. I forgot to mention something. What was the degree of this function again? 3. How many real zeros did I get? 3. Remember, that's the maximum number of real zeros you can get. If we thought it crossed the x-axis 5 times, we'd know we were wrong because it's not a choice. It can't be more than 3. It can be less than 3, but it can't be more. Okay? That's it. Questions? Okay.